So for walk around problems, what ends up happening is you end up having a whole bunch of tangents, or the two tangent theorems, I should say. Do you see how AN and AM are two tangents from the same point A, and CM and CP are two tangents from the same point C, and BN and BP are two tangents from the same point B? Right, and what happens when we have two, what happens with the two tangent theorem? They're congruent. So I know that AN is congruent to AM. I also know that BN is congruent to BP. And I know CM is congruent to CP. All right, now there's two different kinds of walkarounds. There's a triangle walkaround. This is a triangle walkaround, and there's a quadrilateral walkaround. We'll get to the quadrilateral walkarounds. So this is a triangle walkaround because there's the triangle, right? So for both quadrilateral and triangle walkarounds, what you're going to do is you're going to pick any segment and call it X. It does not matter which segment you call X. Oh, sorry. I forgot to label. It says that AB is 6, AC is 8, and BC is 10. Hey, so I'm going to pick any segment. I'm going to call it X. So I'm going to go ahead and I'm going to call AN X. If AN is X, which other segment is X? AM is also X. All right, now stay with me. For some reason, kids get confused with the X, but it's no different. Let's say AN was 2. Let's just pretend. If AN was 2, how long would N be? What would be the length of NB? What'd you do?
6 minus 2.
Good. We all agree if AN was 2, NB would be 4. We'd do 6 minus 2, that would give us 4, right? Well, we don't know how long AN is, but wouldn't it just be the whole segment minus that portion? So it would be 6 minus X. Do you know what a lot of students write? Any guesses? They write X minus 6. Why can't it be X minus 6? Why does it have to be 6 minus X? Erin?
Can it be a negative?
Excellent. It would be a negative. Can we ever have a negative length? It's always big minus small, right? So this segment is going to be 6 minus X. Well, if NB is 6 minus X, which other segment has to be 6 minus X?
BP.
You got it. BP would be 6 minus X. All right, now I'm jumping back. Where do you think I'm going to jump to? Any ideas? Where am I going to jump to now? You got, nope, not N. There is no NC. Good. We're going to jump back to AC. We're jumping back to AC. The whole AC is 8, AM is X. You tell me, how long is CM going to be represented by? The length of CM, how are we going to represent that?
8 minus X.
You got it, 8 minus X. And if MC is 8 minus X, which other segment is 8 minus X?
PC.
PC, you got it. Okay, so now what we're going to do is we're going to pick a side where the X's do not cancel. We're going to pick the side where the X's do not cancel. What do I mean? AB, if I add them together, X plus 6 minus X, won't they just cancel? And here for AC, if I add them together, X plus 8 minus X, wouldn't the X's just cancel? All right, so I'm choosing the side where the X's do not cancel. 6 minus X plus 8 minus X. Negative X plus a negative X is a negative 2X. Are we okay there? Yeah, so you choose the side where the X's do not cancel. So I'm going to go with BC. And what do we know? We know that BC, its total length is 10. Do we agree on that? BC's total length is 10. So what does that mean? That means 6 minus x plus 8 minus x has to equal 10. Combine your like terms. I have negative 2x plus 14 equals 10. Negative 2x equals negative 4. X will equal 2. Now that we know what x is equal, can't we find the length of all the segments they're asking for? So the first thing they said is find AN. Well, AN is x, so what do we know x is? 2. What about BP? How are we going to find the length of BP? What should we do? You got it. 6 minus 2, which is 4. What about CM? How are we going to find the length of CM? How are we going to find the length of CM?
8 minus 2.
You got it. 8 minus 2, which is 6. All right, I want you guys to try number 2. You all try number 2 on your own. All right, let's go through this. So I know because of the two tangent theorem, the segments that I'm marking are congruent. We know that AC is 8. We know that CE is 10 and AE is 12. By the way, it doesn't matter where you put the X. How many put the X on AB? Because that was the first thing asked. Perfectly fine. So let's go that route. If we put the X on AB, that means AF is also X. FE will be 12 minus X, which means ED is 12 minus X. I'm jumping back now to AC. Again, if AB is X, then BC is 8 minus X, which means DC is 8 minus X. Which side, if you chose X on AB, which side are we going to use for our equation? Which side are we going to use for our equation, Caleb? EC, you got it. We're going to have 12 minus X plus 8 minus X equals 10. So we are negative 2X plus 20 equals 10. Negative 2X equals negative 10. X is equal to 5. So AB is 5. BC is going to be 8 minus 5, which is 3. ED is going to be 12 minus 5, which is 7. How many people got that all correct? Excellent. All right, so now we're doing more walkarounds. They're still triangle walkarounds. They're just a little bit different. because now I have 3 circles and the triangles connecting their center points. The triangles created by connecting their center points. But essentially, it's going to be the same process as the other triangle walk around. Let's see what it says. It says that AC is 9, BC is 11, and AB is 14. Right. Now, there's no two-tangent theorem here. There's no two-tangent theorem here. But don't we know radii of the same circle are congruent? So now I'm going to circle O, and I'm going to mark, circle A, and I'm going to mark circle A's radii congruent. Then I'm going to go to circle B, and I'm going to mark circle B's radii congruent. Then I'm going to go to circle C and mark circle C's radii congruent. And then it says find the radius of circle A. So I'm going to go to circle A and call it X. Hey, well then isn't the other side of the other radius for circle A also X? Someone tell me, how would I represent the radius for circle B? How would I represent the radius for circle B? Aaron? You got it. So the radius of circle B is 14 minus X, and that's on both radii of circle B. Now I'm jumping back to AC. I know the radius of circle A is X. Somebody tell me, how am I going to represent the radius of circle C? 9 minus X. And so both the radii for circle C will be 9 minus X. Similar to the other triangle walk around, this is still a triangle walk around because we have the triangle shape. You go to the side that won't cancel. Which side will not cancel? Which side will not cancel the X's? James? BC. So that's where we make our equation. So we're going to say 9 minus X plus 14 minus X equals 11. So we have negative 2X plus 23 equals 11. Subtract the 23, and we're going to have negative 2X equals 12. Negative 12. X will equal 6. So radius of circle A is 6. Radius of circle B is going to be 14 minus 6, which is 8. Radius of circle C is going to be 9 minus 6, which is 3. All right, you guys try this next one on your own. You all try number 4 on your own. All right. So number 4, we have AC is 20. We have BC is 18, and we have AB is 14. Remember, radii of the same circle are congruent, so the radius for circle C are congruent, the radii for circle B are congruent, the radii for circle A are congruent. It says find the radius of circle A, so I don't know, it really doesn't matter what you call X. I went to circle A and called that radius X. So then the radius on the other side of A is also X. The radius for circle C will be 20 minus X. The radius for circle B, now I'm jumping to AB, will be 14 minus X. So we choose the side where the x's do not cancel. This time, that's going to be BC. So we are 20 minus x plus 14 minus x equals 18. Negative 2x plus 34 equals 18. Subtract that 34. We're going to have negative 2x is equal to negative 16. Thank you. X will equal positive 8. So circle A is x, that's 8. Circle B is going to be 14 minus 8, which is 6. And circle C will be 20 minus 8, which is 12. How many people got that all correct? Great. All right, the last kind of walk around is a quadrilateral walk around. All right, the setup for the quadrilateral walk around is pretty similar. It's the solving part that's different. So for the triangle walk around, we go to the side where the x doesn't cancel, right? For the quadrilateral walk around, we do let the x cancel. And I'll show you what I mean. So, do we all agree about the two tangent theorem applies here? All right. Do you see all the points that don't have letters? Let's give them letters. Let's call them L, M, N, P, just so I can refer to them. All right, so we are told that AD is 10, that CD is 15, and AB is 18. We want to find the full length of BC. We're going to go to a segment and we're going to call it X. If you want the most strategic way to make this the easiest way possible, don't call any part of BC X. Don't call any part of BC X. Go to a different side far away from BC, and call one of those segments X's. It's going to make it a little bit easier. So I'm going to go to AP and I'm going to call it X. If AP is X, which other segment is X? AL. Good, Mariana. All right, somebody tell me, how would I represent BL? How would I represent BL based on how everything is marked?
18 minus x.
You got it. And if BL is 18 minus x, do we all agree BM is also 18 minus x? All right, stop, jump back. Where do you think I'm jumping back to? Which side? AD, exactly. We're going to jump back to AD. Now remember, right? AP is X, AD is 10. How am I going to represent PD? 10 minus X. If PD is 10 minus X, since they're congruent, DN is 10 minus X. Now it's going to become a little bit more complicated, meaning the arithmetic or the algebra part of this will get a little bit more complicated, but it's not bad, right? Do we all agree that NC will be 15 minus this portion, 10 minus X? All right, you have to be careful when you do that. I'm going to go over to the side, and I'm going to do 15 minus. You need parentheses. If you do not have parentheses, it's going to be wrong. In parentheses, 10 minus x. Because that subtraction is not only subtracting the 10, it also needs to subtract that negative x. So it's 15 minus this whole thing, which is 10 minus x. So now I'm going to get 15 minus 10. What's a negative or a minus times a negative x? Isn't that a positive x? So now let's simplify. 15 minus 10 is 5 plus x. So NC is 5 plus x. If NC is 5 plus x, then CNM is 5 plus x. Have I lost anybody? We're still good? Still good. Okay, now If it were a triangle walk around, we'd go to the side that didn't cancel and we'd make an equation, right? That's not what we want for a quadrilateral walk around. For a quadrilateral walk around, whatever side they tell you to find, so I told you to find BC. You go to side BC and you just simplify that side. So BC will equal 18 minus x plus 5 plus x. And this time the x's should cancel. Negative x plus a positive x cancels. So then we're left with 18 plus 5, which is 23. So BC is 23 units long. That will always happen if you do it correctly for a quadrilateral walk around. When you simplify down the side, the x's will cancel and you'll just be left with a number to represent that side. All right, you all try number 6 on your own, and then we will call it a day. Yes.
I go to the front office.
All right, we only have a few minutes left. I solved the problem. Did anybody get to finish it yet?
Yeah.
What, if you finished it, did y'all get 11? No?
9. Yeah, 9. I think the one's supposed to be negative.
Oh, did I do something wrong?
You get 10 minus 1.
I got, it should be 10 minus 1. What did I put? Oh, I put plus 1. Thank you. This is an x plus an x minus 1. There we go. All right, if you all finished it now, did you all get 9? Okay, awesome. So